Rapid response observations by major observatories shows that the first known interstellar visitor is 10 times longer than it is wide. In Arthur C. Clarke's 1973 science fiction novel Rendezvous with Rama, Earthlings discover and then investigate an interstellar asteroid that turns out to be a huge alien spaceship shaped like a long cylinder. Life, it seems, sometimes imitates art. In the days after the discovery of Oumuamua, the first real interstellar object ever known to pass through our solar system, astronomers worldwide went on the astronomical equivalent of red alert and pointed the biggest guns at the unexpected interloper. "We dropped everything," explains Laura Ferraris, who coordinated observations by the Gemini South Observatory in Chile. The result was a torrent of observations and speculations that have already found the way into many analyses posted online. Artists' concept of interstellar asteroid 1I2017U1 Oumuamua as it passed through the solar system after its discovery in October 2017. The aspect ratio of up to 101 is unlike that of any object seen in our own solar system. ESOM. Professor earlier looks at these data show that 1I2017U1, as it's now known officially with I denoting interstellar, has a reddish color not unlike the surfaces of comets and other distant, primitive objects in the solar system. Yet not even the most powerful telescopes revealed any hint of cometary activity, even though this body passed well inside Mercury's orbit at about 0.25 astronomical unit from the Sun. While the mystery object's spectrum seems reasonable, its shape borders on bizarre. According to rapid response observations pulled from 5 large telescopes in Hawaii and Chile, the apparent brightness of 1I2017U1 varies periodically and shows about 2.5 magnitudes of range. Of the roughly 750,000 asteroids now known, only 5 display light curves with swings of at least 2.2 magnitudes, and none as high as 2.5. As Karen Meach, University of Hawaii and others explain in a Nature article posted online on November 20, this wide swing implies that the object has an extremely elongated shape, perhaps 10 times longer than it is wide. If Oumuamua has a very dark surface that reflects only 4% of sunlight, then its average diameter must be a bit more than 100 meters, 330 feet across. But that's a rather meaningless mean given the extreme light curve. Instead, note Meach and her colleagues, the true shape must be 800 meters, 0.5 mile long and only 80 meters across, more like a gigantic spindle, a cigar than a ball of rock. As the team notes, it raises the question of why the first known interstellar object is so unusual. This plot shows how the interstellar asteroid Oumuamua varied in brightness by a factor of 10 during 3 days in October 2017. The colored dots represent measurements through different filters, covering the visible and near-infrared part of the spectrum. The dotted line shows the light curve expected if Oumuamua were a cigar-shaped ellipsoid with a 110 aspect ratio. The deviations from this line are probably due to irregularities in the object's shape or surface albedo. ESOK Meach al. The combined light curve shows that Oumuamua rotates every 7.8 hours. Assuming that the spin axis goes through its shortest dimension, the most likely situation, this interstellar visitor must be made of rocky or metallic compounds with a fair amount of tensile strength to keep from flying apart. Where did this thing come from? Conceivably, it could have come from our solar system. You can imagine that it might have been circling the Sun somewhere in the no-man's land of the inner Oort cloud when it had a chance close encounter with some massive unseen planet that abruptly flung it sunward. But no one is exploring this scenario seriously. Instead, this interstellar cigar seems to have entered our solar system from the direction of the constellation Lyra at about 26 kilometers 16 miles per second. Its velocity and incoming direction, dynamicists note, matches the mean motion of stars in the Sun's neighborhood almost exactly. We might never determine which star Oumuamua escaped from. It could be a renegade from a young system just a few million years old, or perhaps it's been floating freely among the stars for billions of years. Fittingly, Oumuamua loosely means a messenger that reaches out from the distant past. Meach and her colleagues point out one other oddity about 1I2017U1. In their infancy, the young planets of our solar system tossed and told trillions of objects out to the distant Oort cloud and beyond. And while a handful of asteroidal bodies do lie at the solar system's outer fringe, ice-free comets dominate overwhelmingly, at estimated ratios of 2001 to 10,001. If this proportion holds true for the cast-offs of other stars, then by any reasonable odds, oumuamua should have been a comet. And finally, consider that, statistically, interstellar objects ISOs should NT be rare. Our estimates suggest that there is always about one ISO of about 250 meters diameter, assuming 4% albedo within 1 AU of the Sun, that is, interior to Earth's orbit, the team writes. These objects might not be rare after all, we simply need to be alert for the next one to pass our way. For more details on the contributions of the observatories that contributed to the Nature article, check out these press releases from the University of Hawaii, European Southern Observatory, Gemini Observatory, and